Hey guys, good afternoon, and welcome to another video as well. I'm going to be using Python and the Sympy, um, a symbolic packaging that's written in Python code. And so it does a lot of computational mathematics and stuff. So yeah, so I'm just going to start off by importing the package. So sorry, so from Sympy import, right, and then initial printing, then pretty print. Right. So MathJax here is it's just a way of writing symbolical math in a neat way in web browsers and stuff. So it's used by developers in JavaScript and everything else. So I also like using it here as well. So it just kind of makes it really look pretty, hence the word pretty print. Okay. So yeah, and then what I'm gonna start off doing is I'm gonna assign my matrices to variables. Then it's just easier to call them. And the plan is I'm going to be showing you this theorem. So let A, B, C be matrices. Then whenever the products and the sums are defined, then you get all these like laws, associative law, left distributive law, and so forth. So I'm just going to show you that using different matrices. Okay, so yeah, so I'll go back to the Python shell. Okay, so my matrix A, right, so that'll be 1, 0, and then random number -1, 2, and B will be, right, let me just think of another one. So 3, 1, 0, 1, and then C, that'll be matrix. Random numbers again. So I think 1, 1, I'll go for, sorry, 1, 1, and then 1 and 2. Okay, so these are matrices. And then, so what I need to show you is the first law. So A times B times C equals that, the associative law. So I'll call it, I'll give it a variable name as well. So I'll call it F, and so AB. Then G, I'll call it that. Okay, so then I need to prove that it's true. So what I'll do is I'll just use the logic way. So that's true. Okay, so that qualifies that, the associative law. Then the left distributive law as well. So I'll just do that again. So H. That's true again. So that's the left distributive law, right? Then I'll do the right distributive law. and that's true again. And then so that's the right distributive law. Then I'll do the scalar law. So I'll use a random number. I'll just use I'll use 3. I'll use 3. So JK. Then N, I'll call it so 3 times A times B. Then I'll call that P, the next one, which will be okay. So then I'll just do the final thing as well. So M is M equal to N, or is also equal to P. That's true. Okay. I could have done it the long-winded way by doing it like so. So M, right, and then N, right, and then M, right. So whichever way. Yeah. So it's just a neat thing about matrices when products and sums are defined. So you can obviously show these laws, but then obviously anything if it's zero, like a zero matrix, then obviously that doesn't hold. Okay. So hopefully it's useful for anyone that's interested in linear algebra. Okay. So my final note. I'm just going to say happy Saturday and enjoy the rest of your day. Right, thank you guys. Cheers. Bye bye.